Hello, dear listeners, and welcome to Sleepy Science Teller, a quiet place where curiosity drifts gently through the night, where science meets peace and every question becomes a lullaby for the mind. I'm so happy you're here, ready to unwind as we explore one of the most mysterious ideas in the universe. Why does time only move forward? Time surrounds us. It flows from morning to night, from birth to old age, from the first spark of the universe to the fading glow of distant stars. But have you ever wondered why time doesn't run backward? Why broken glass doesn't reassemble? Why memories form behind us, not ahead? Tonight we'll journey softly through science and wonder to understand why time only moves forward. Before we begin, take a deep breath and let yourself settle into stillness. If you like, share in the comments where you are right now and what time it is. It's always so lovely to imagine people all around the world lying back, listening at the same time, yet each in their own moment. And while you're here, if you enjoy drifting through these gentle bedtime discoveries, please tap the like button and softly subscribe so you never miss a night of calm curiosity. Time, it's the quiet river that carries us through everything we experience. From the first cry of birth to the final sigh of sleep, it moves, always forward, never back. You wake in the morning, sunlight spilling across your room. You stretch, blink, breathe, and another moment has passed. No matter how still you sit or how long you close your eyes, time continues its gentle march. We feel it slipping not as a sound, not as a sight, but as a presence, a constant background rhythm that never repeats itself in quite the same way. If you've ever watched rain running down a window pane, you might have noticed how every droplet follows its own path. They may cross or join or separate again, but none of them ever climb back upward. That's what time feels like, a downward flow, smooth and irreversible. But what does it really mean for time to move forward? Forward relative to what? The past is behind us, the future ahead. But those are just words we've invented to describe something we don't yet fully understand. In physics, time is treated as a dimension much like space. We can move left or right, up or down, but through time, we can only move one way. That one-way movement gives life its structure, cause before effect, birth before death, sunrise before sunset. You can think of time as a story being written, letter by letter. Each word depends on the one before it, and the ending can't appear before the beginning has been told. In the same way, the universe unfolds one moment at a time, writing itself continuously, page by page, with no way to turn back. Scientists have often wondered why time should have this direction. The laws of nature, the equations that govern gravity, light, and motion, don't actually forbid time from running in reverse. If you were to watch two planets orbiting each other, the physics would look perfectly valid, whether the film ran forward or backward. So why, then, does everything we experience have a clear direction? Why do we remember yesterday, but not tomorrow? Why does milk spill out of glass but never leap back in? This question, the mystery of time's direction, has puzzled scientists for centuries. Some have called it the arrow of existence, a single invisible line that points all things toward the future. And even now, even after all our exploration, we still don't have a simple answer. But maybe that's what makes time so beautiful. Its mystery is what gives life its meaning. Because if time could go backward, we might never feel the urgency to live, to love, to change. Every moment would be repeatable every mistake erasable, every ending reversible. Instead, time gives us a gift, the gift of impermanence. Every breath, every heartbeat, every sunrise happens only once. And perhaps that's the quiet secret of why we cherish them so deeply. As the stars drift above and your mind begins to soften, let's move a little deeper into this mystery and explore how science sees the arrow of time. If you imagine the universe as a great cosmic movie, then time is the direction in which the film is being played. Frame after frame, moment after moment, the story unfolds. But unlike an ordinary film, we cannot rewind it. At least, not in the way we experience life. Everything in existence follows the same rule. A flower blooms, then wilts. A wave rises, then falls. A star ignites, then fades into the quiet blackness of space. Each is a chapter in the book of time, written only once. But if the laws of physics are symmetrical, meaning they work just as well backward as forward, then why does the universe itself prefer the forward flow? The answer lies not in the equations themselves, but in the initial conditions, how everything began. Long ago, before galaxies, before stars, there was only the infant universe, hot, dense, and full of energy. In that beginning, everything was extremely ordered. Energy was neatly packed, tightly contained. From that moment, as the universe began to expand, disorder or entropy began to rise. And from that increase, the direction of time was born. But we'll come to entropy soon. For now, let's stay with the feeling of time, its texture, its rhythm, its subtle pull. Think of how your memories work. They're like photographs taken in one direction only. You can remember breakfast, but not dinner tomorrow. You can recall a melody you've heard, but not one you'll hear next week. That's because your brain, like the universe, records information in a forward-moving way. Neurons strengthen their connections from experience to memory, but they never reach backward to pre-write what hasn't yet occurred. So perhaps the mystery of time's direction isn't just in physics. It's also in consciousness. We feel time moving forward because that's how we process change. The very idea of before and after exists only because our minds notice differences. You can test this quietly even now. Close your eyes. Listen to the hum of your surroundings, maybe the faint sound of air, the ticking of a clock, or the rhythm of your own breath. Each moment feels new, doesn't it? Because your mind is measuring it, comparing one instant to the next. That measuring, that noticing, is how your brain creates the sensation of time passing. In a way, time's direction exists only because we can remember. Without memory, there will be no sense of past. And without anticipation, there would be no future. There would only be an eternal now. It's strange to think that time's direction could depend on how life perceives it. But even if we strip perception away and look at the universe purely through mathematics, we find that its evolution, from smooth to scattered, from simple to complex, always moves one way. And that direction feels irreversible, like an egg falling from a table. Once it breaks, the pattern of pieces can't spontaneously reassemble. That's not because the laws of motion forbid it, but because it's so unlikely that it might as well be impossible. And that impossibility is one of time's quietest secrets. When you stand at the edge of the ocean and watch waves rolling toward shore, you're witnessing the same principle that governs time. Each wave travels forward, carrying energy that disperses when it breaks. never the other way around. The universe behaves in much the same way. Energy moves, spreads, and settles always onward. Scientists call this phenomenon time asymmetry. It's the simple idea that while space looks the same in every direction, time does not. The past and future aren't mirror images. They are separated by the irreversible changes that happen in between. Imagine a forest fire spreading through a valley. The flames consume the wood, the air fills with smoke, and afterward, only ash remains. Nothing in the laws of physics says those ashes couldn't suddenly reassemble into trees and leap back into green, living form. But in reality, it never happens, because the probability is unimaginably small. And in that tiny unlikelihood, time finds its direction. The deeper scientists look, the more they realize that time's arrow might not be a thing that exists by itself. It might simply be the universe's tendency toward greater possibility, toward configurations that are more likely than those before them. Order narrows choices. Disorder multiplies them. So the universe keeps moving forward into realms of greater variety, and we, living within it, experience that expansion as time. Even Einstein, who unified space and time into a single fabric, couldn't explain why the fabric has a front and a back. He described how time bends and stretches near gravity, how it slows beside a black hole and races freely in empty space. But the question of direction, why clocks always tick the same way, remained unsolved. In quiet moments, philosophers and physicists alike have wondered if perhaps forward is only an illusion of perception, a byproduct of how we experience change. Yet every experiment, every observation, still shows the same steady truth. Events unfold one way and never the other. So maybe time's mystery isn't meant to be solved, but felt, like the pull of gravity, or the warmth of sunlight through a window. It's something we live within, without needing to fully understand. You, right now, are drifting through time, not just across seconds, but across the grand current that has been flowing since the birth of the cosmos, from stars collapsing into dust, to dust forming new stars. The universe is always moving forward, and so are you. The mystery of time's direction is also the mystery of your own existence. Every breath you take is the present becoming the past. Every thought you have is a ripple in the stream, and in that continuous movement, quiet, unstoppable, and endlessly gentle, we find the heartbeat of everything that has ever been. As you let your thoughts drift and your breathing slow, perhaps it's enough simply to know this. Time's direction is not a trap, but a gift, a reminder that each moment, once gone, becomes part of the story that can never be repeated and never needs to be. Imagine standing in a quiet field. As dawn begins to bloom across the horizon, the light touches the grass, the air warms, and a new day unfolds. You don't see the night rushing backward, or the stars returning to their places. You see only forward motion, a continuation of what has already begun. This is the arrow of time. It's one of the most fundamental patterns of the universe. The reason why everything happens in sequence, and why events never reverse themselves. If you drop a pebble into a still pond, ripples move outward, never inward. A cup shatters, never reforms. A candle burns down, never grows taller again. That is the unmistakable signature of time's arrow, its unyielding preference for forward. But what does forward really mean? To us, it's a direction, a sense of progression from yesterday to today to tomorrow. To the universe, however, forward isn't marked by calendars or clocks. It's defined by change itself. Whenever something transforms, a leaf turning brown, a star collapsing, a seed sprouting, time is passing, and those transformations, for reasons buried deep in the structure of physics, can only occur one way. It's curious, isn't it, that most of the laws of nature don't actually care about direction. If you were to look at the equations that describe motion, or light, or gravity, they'd work just as perfectly in reverse. Run the math backward, and everything still makes sense. So why, then, does our world behave differently? Why do we always move from the past to the future, and never the other way around? To understand that, scientists describe time's direction as an arrow, a symbol of asymmetry. While space allows you to move in any direction, time has only one. It is the ultimate one-way street. No matter how fast you travel, how far you go, you cannot turn back. And yet, this arrow is not imposed by any single law of physics. It emerges from the way the universe began, and the way entropy, that gentle spreading of energy and disorder, has been increasing ever since. But before we reach entropy, let's linger here and think about what it feels like to live along the arrow of time. Every heartbeat, every blink, is a small step forward along that invisible line. Our memories stretch behind us like footprints in the sand. The future lies ahead, untouched, like smooth, unmarked shore. And the present, the brief point where your foot meets the ground, is all that truly exists. In this sense, the arrow of time isn't just physical, it's emotional. It gives our lives structure, a beginning, a middle, and an end. Without it, there would be no progress, no story, no meaning, because every story, no matter how vast or small, depends on sequence, on before and after. So when scientists speak of the arrow of time, they are really speaking about something both cosmic and intimate. It governs galaxies and governs us. It turns chaos into experience. It takes possibility and turns it into memory. And as the minutes pass, softly, inevitably, we move further along its gentle, irreversible path. Think for a moment about how you know that time is passing. You can't see time itself. You can't hold it, or slow it, or point to where it begins or ends. But you can see its effects in melting ice, in falling leaves, in the fading glow of evening light. These changes are the fingerprints of time's arrow, left on everything around us. When a snowflake touches your skin, it melts instantly. That melting, that shift from solid to liquid, is the arrow of time in action. The molecules have moved to a more disordered state, and that change can't simply reverse itself. The flake cannot unmelt. If you record a video of it melting, you can watch it backward, and for a moment, it might look as if the drop of water reforms into a flake. But your mind instantly knows it's wrong, because even without calculation, you feel the arrow of time. Your intuition, your biology, your memories, all aligned in the same direction. Even your body keeps time's rhythm. Cells divide, then age. Muscles grow, then tire. Each moment leaves a tiny mark, a trace of what once was, a clue that cannot be reversed. If time could truly move backward, you would unlearn your experiences. Your thoughts would return to innocence, and the universe would unwind like a film reel spinning the wrong way. But that never happens. The arrow holds steady. Scientists sometimes visualize the arrow using thermodynamics. the study of energy and heat. Whenever energy flows from one place to another, say, from a warm cup of tea to the cooler air around it, that process is irreversible. The tea cools, the room warms ever so slightly, and the balance of energy changes forever. No natural force restores that warmth to the cup by itself. This is the arrow of time written in heat, a flow that can only move in one direction. Our very existence depends on it. Stars burn fuel, releasing light that travels through space, lighting worlds like ours. That flow of energy, from concentrated to dispersed, powers everything from sunlight to thought. Without the arrow of time, there would be no aging stars, no growing plants, no living moments. You can see the same principle in your daily life. When you bake bread, the ingredients combine, heat transforms them, and something new emerges. The process can't go in reverse. You can't unbake a loaf. Nature always chooses a simpler, more likely direction, the one that spreads energy outward. And that, in essence, is the arrow of time made visible in your kitchen, in every example. Cooling tea, melting snow, burning stars. The story is the same. Things move from concentrated to diffuse, from ordered to mixed, from potential to memory. The arrow never wavers. And through that simple, unstoppable motion, the universe writes its story, one irreversible change at a time. If you could step outside of time and look upon the universe as a whole, past, present, and future all at once, you might see something astonishing. A vast cosmic timeline, stretching from the Big Bang to the distant future, filled with stars being born and fading, galaxies colliding, atoms forming and dissolving. Every event, no matter how small, is arranged along that single line, the arrow of time. It began, we think, at the moment of creation, when the universe was at its most ordered, its most compact. Since then, entropy has been increasing, and with it, the arrow of time has continued its endless forward glide. But there's a strange twist to this story. The deeper scientists look, the more they find that the microscopic world, the world of particles and atoms, doesn't seem to care about direction at all. An electron spinning around a nucleus behaves the same, whether time moves forward or backward. It's only when trillions of such particles come together, forming stars, oceans, and people, that time's arrow becomes visible. In that way, the arrow of time is an emergent property, a grand pattern rising out of the collective behavior of countless smaller things, like the flow of a river made of billions of water molecules. Each molecule can move in any direction, but together they create a current that always moves one way, and we are carried by that current. Our hearts beat in rhythm with the cosmic flow. Our lives unfold along the same irreversible stream. Every sunrise, every memory, every dream is a single moment along that path. The arrow of time defines existence itself. It's the reason we can learn from yesterday and look forward to tomorrow. It's what makes music possible. Notes unfolding in sequence, melody following rhythm. It's what gives every story meaning, each beginning leading toward an end. Some scientists have imagined what might happen if the universe ever reached perfect stillness again, a state of total equilibrium. If that day comes, the arrow of time might finally fade. No heat would flow, no energy would move, and the universe would rest in quiet balance, an endless moment without before or after. But until then, the arrow keeps pointing forward. It guides stars, atoms, and hearts alike. And maybe as we move through our lives, we can find comfort in that, in knowing that forward motion is not our burden, but our nature. Every choice we make, every breath we take, is part of the arrow's great unfolding, a continuation of a story that began long before us and will continue long after. Time's arrow does not ask permission. It simply flows, and all we can do is flow with it, gently, gratefully, toward whatever lies ahead. There's a quiet rule that guides the universe. It whispers behind every change, every transformation, every unfolding moment. It's not loud or visible, yet it shapes everything, from the way stars shine to the way your cup of tea cools beside you. That rule is the second law of thermodynamics, and at its heart lies a mysterious idea of entropy. Entropy is a word scientists use to describe how ordered or disordered a system is. When things are neat, structured, and perfectly arranged, we say they have low entropy. When they're scattered, mixed, and random, their entropy is high. You can see this everywhere. In the kitchen, when you crack an egg, the smooth, clear yolk and white spill into a messy mixture. That's entropy increasing. In your room, when you stop cleaning for a few days, objects slowly spread out, chaos grows, and order fades. That's entropy again. The second law of thermodynamics tells us something profound. It says that in a closed system, a place where no energy or matter enters or leaves, entropy always increases over time. Always. Things move naturally from order to disorder, from concentrated energy to dispersed, from tidy to tangled. And that one simple rule is the reason time has direction. Imagine you're holding a deck of cards, perfectly arranged in order, ace through king. Now you shuffle them. Each shuffle increases the randomness, making it harder to return to the original arrangement. Could you shuffle enough times to get back that perfect order? Yes, in theory, but it would take a near infinite number of tries. So practically, it never happens. The universe behaves the same way. At its birth, during the Big Bang, everything was perfectly arranged. Low entropy. As the universe expanded, energy spread out. Galaxies formed, stars ignited, worlds spun into being, and with every passing second, entropy rose a little higher. This increase is like a cosmic arrow, pointing forward through time. It tells us why things age, why ice melts, why fires burn out, and why nothing ever quite returns to the way it was. But entropy isn't simply chaos. It's also possibility, because as order breaks apart, new combinations emerge. Stars die, and their dust becomes new planets. Old forests decay, and nourish new growth. Even the cells in your body, as they live and divide, follow the same flow, energy dispersing, patterns rearranging. So entropy is not destruction. It's transformation. In every gentle unraveling, something new has a chance to appear. The second law doesn't say that order disappears forever, only that it changes form, scattering energy into new patterns of existence. If you ever felt time slipping by, like sand falling through your fingers, you felt entropy. But instead of sadness, there's beauty in it. A reminder that every ending, every scattering, is part of a larger, graceful dance. Entropy gives time its heartbeat. It keeps the universe moving forward, and in that slow, unstoppable motion, we find both meaning and peace. Now, imagine standing at the edge of a forest, watching autumn leaves fall. One by one, they drift downward, settling softly into a golden carpet. Each leaf moves randomly, but together they form a pattern, a gentle spreading of color and form. This is entropy in motion, a natural process, moving from organized branches to scattered ground. And yet, the forest doesn't mourn the change, because in that scattering, new balance begins. Entropy, in its essence, isn't about destruction at all. It's about energy finding equilibrium. Every hot object cools. Every dense cloud expands. Every structure eventually relaxes into balance. That balance, that even spread of energy, is what the universe is always reaching for. The second law of thermodynamics tells us that every process, from boiling water to the beating of your heart, moves energy from areas of concentration to areas of emptiness. Hot becomes cold, full becomes empty, order becomes disorder, until one day everything settles. Scientists call that final, peaceful balance thermal equilibrium. It's a state where all energy is evenly spread, no movement, no difference, no more change. It's quiet, utterly quiet. But we are far, far from that. Our universe is still alive with imbalance. Stars burn fiercely, galaxies collide, and life thrives on the uneven exchange of heat and energy. Every gust of wind, every heartbeat, every spark of thought is a little pocket of order, trying to resist the natural spread of entropy. And that's what makes life extraordinary. Because while entropy increases overall, life creates temporary islands of order. Your body, right now, is using energy to maintain structure, to keep your temperature steady, your heartbeat rhythmic, your thoughts flowing. You are, in a way, a small rebellion against entropy. But even that rebellion has a cost, because keeping order requires releasing heat and waste. And that release feeds entropy once again. It's a perfect balance. Every act of creation, whether it's a blooming flower, a burning candle, or a human thought, comes with a quiet whisper of disorder. Nothing is lost, but everything changes form. There's comfort in that idea, because it means that endings and beginnings are not opposites, they're partners. The old making way for the new, the structured giving rise to the possible. And through that never-ending exchange, the universe breathes. The physicist Ludwig Boltzmann once said that entropy is the measure of the number of possible states a system can take. The more possible ways energy can arrange itself, the higher the entropy. So as entropy rises, the universe doesn't fall apart. It becomes richer in possibility. From a single spark, an infinity of arrangements can emerge. That's what the second law describes. Not decay, but potential. And so, the forest that loses its leaves isn't dying. It's opening the door to what comes next, to the seedling that will rise, to the soil that will nourish. Entropy is the quiet architect of renewal, far beyond our world, in the silent black of space. Entropy plays its part on a grander scale. Stars burn their fuel, turning hydrogen into heavier elements. That process releases energy, light, and heat, spreading order into disorder and filling the universe with radiation. When a star dies, it explodes, A supernova scattering its elements into space. Those scattered atoms drift, collide, and form new stars, new planets, new beginnings. The chaos left behind becomes a cradle for creation. That's entropy again, shaping the cosmos through endless transformation. The second law tells us that energy never stops moving forward. Even as galaxies spread farther apart and starlight fades, entropy continues to rise. Eventually, perhaps billions upon billions of years from now, the universe will reach what scientists call heat death, a state of perfect equilibrium where all energy is evenly distributed and no work can be done. No more stars, no more warmth, no more change, just stillness. But don't let that thought bring sadness, because what it truly means is that the universe will have completed its long, elegant journey toward balance. Every spark, every birth, every heartbeat will have been part of that journey. And right now, we are living in its vibrant middle chapters, the age of stars, of light, of discovery. Entropy is not the enemy of time. It is time's compass. It's what tells the universe which way to go and what keeps the story unfolding. Without it, nothing would ever happen. There would be no sunrise, no sound, no thought. It is entropy that allows motion, and motion that creates life. You can think of it like this. Entropy is the universe's way of remembering that change is beautiful. It takes everything, every moment, every atom, and weaves them into something new, always forward. So when you see a melting candle, or a drifting cloud, or the last ripple of a stone dropped into water, remember, you are witnessing the same law that governs galaxies. Entropy and the second law of thermodynamics are the quiet storytellers of time. They remind us that life isn't about holding on to order, but flowing gracefully with change. The candle doesn't mourn its flame. It simply passes its light onward. And in that same way, we too are part of the great, unending balance. Entropy may lead all things toward stillness, but it also fills every moment with meaning, because in every flicker of heat, every breath of wind, every heartbeat that comes and goes, it whispers the same eternal truth, that everything changes, and that change is the reason time moves forward. Imagine holding a cup of hot tea, freshly poured, steaming softly in the cool evening air. You can feel the warmth radiating gently against your hands. But as time passes, the heat slowly fades. The tea grows cooler, the steam thins, and the once vibrant warmth disperses into the surrounding air. That is disorder increasing. Every moment, everywhere in the universe, the same quiet process unfolds. Energy spreads, order loosens, and patterns dissolve. It happens so naturally, so effortlessly, that we hardly notice. And yet, it's the foundation of everything that moves forward in time. When physicists talk about disorder, they don't mean messiness in a moral sense, not chaos in the way we think of confusion or destruction. They mean a natural redistribution, a tendency of things to spread out, to share energy evenly, to relax from structure into freedom. Think of a perfume bottle, open in the center of a quiet room. At first, the fragrance is concentrated in one small place, high order, but slowly the molecules drift outward, spreading across the air until the scent fills the entire space evenly. That's the universe's most basic rhythm, the transition from concentrated order to graceful diffusion. We see it in every aspect of life, in the way ice melts into water, in how sugar dissolves in tea, in how clouds form, drift, and disappear. Each time, energy moves from one form into another, more spread out, less confined. It's not destruction, it's release. From the tiniest particle to the grandest galaxy, this flow toward greater disorder is constant and unstoppable. And it's not something to fear. It's something to marvel at, because without it, there would be no motion, no transformation, no life. The philosopher and scientist Rudolf Clausius was among the first to describe this pattern mathematically. When he defined entropy as a measure of disorder in the mid-1800s, he realized that energy never vanishes. It only changes form, moving from useful, concentrated energy to dispersed, less useful energy. Like a ball rolling down a hill, energy seeks balance, spreading naturally until everything rests. When you light a candle, the wax doesn't simply disappear. It transforms. Solid wax becomes liquid. Liquid turns to gas. Gas burns into heat and light. And those energies spread outward, warming the air and glowing softly in the dark. Every flicker of the flame is disorder increasing, a dance of transformation guided by the universe's simplest rule. And so the candle's flame, and the cooling cup of tea, and the drifting clouds above are all part of the same grand unfolding. The universe gently letting go of its concentrated beginnings and moving toward a more even, balanced state. This is how disorder grows, not as chaos or collapse, but as a natural softening, a quiet, inevitable spreading out of energy and matter, like ripples on a calm pond after a stone has fallen in. If you could look at the universe as a whole, you'd see this pattern written everywhere. Galaxies expanding apart, stars exhausting their fuel, atoms vibrating less as they lose heat. The grand story of existence is a story of energy spreading outward, and through that spreading, creating time itself. The increase of disorder isn't a mistake of the universe. It's its heartbeat, the rhythm that keeps everything moving, changing, becoming. Let's drift out now, past the edge of our planet, through the black velvet of space. Look around, you'll see stars, nebulae, and galaxies scattered like jewels. But look closer, and you'll notice something else. A quiet pattern unfolding everywhere. Hot stars radiate their light outward. Cold space absorbs it. Galaxies spin and spread, carrying matter farther apart. Even the afterglow of the Big Bang, the cosmic microwave background, is a sign of energy spreading, cooling, balancing. The universe began as something impossibly dense and ordered. All matter and energy were packed into a single brilliant point. But the instant it expanded, the moment of the Big Bang, that perfect order began to loosen. Energy flowed outward, temperature dropped, and new structures began to form. Over billions of years, that simple expansion became galaxies, stars, planets, and life itself. It's easy to think that disorder sounds negative, but in truth, it's the reason creation exists at all. When things spread and mix, new possibilities appear. Gas clouds collapse into stars. Stars scatter heavy elements into space. Those elements combine to make new worlds, oceans, and eventually living beings. Even within you, the same cosmic rule continues. Every breath you take draws oxygen into your lungs, where it fuels tiny chemical reactions. releasing energy, keeping your body warm, your thoughts alive. Those reactions increase entropy too. In every heartbeat, in every cell, the same principle unfolds. Order breaking down, life emerging in its place. It's humbling to realize that every atom in your body was once part of a star that burned its fuel, increasing disorder to make the very materials of your being. Iron from old sun's courses through your blood. Carbon from ancient nebulae forms your cells. The heat that warms you is the afterglow of the universe's endless diffusion. So the increase of disorder isn't a loss. It's a gift. It's the mechanism through which stars die, and you are born. It's the quiet balance between destruction and creation, woven into the structure of existence. Even time's direction, the way we move only forward, comes from the same pattern. We can't see entropy decrease, because everything we observe depends on energy dispersing. That's why ice melts but never refreezes on its own. Why smoke rises but never returns to the match. Why we remember yesterday, but not tomorrow. It all comes down to the same truth. Disorder naturally grows, and that growth gives time its shape. In every galaxy, in every human life, this increase is steady and certain, but gentle. It doesn't rush. It drifts. It flows. And through it all, the universe continues its quiet unfolding. Not a march toward chaos, but a journey toward balance. Let's rest now in the thought that this growing disorder isn't something to fight, but something to accept, to marvel at. Picture a snowflake landing on your palm. For a moment, it's a masterpiece. Its pattern perfect. Its shape precise. Then it melts. Its order fades. And yet, in that transformation, it becomes part of something larger, a droplet that joins the air, the soil, the life around you. That melting is entropy, but it's also connection. It's the universe redistributing itself, reminding you that nothing is ever truly lost, only changed. The same happens on cosmic scales. Stars collapse, scatter, and reform. Galaxies drift apart, but their light travels endlessly, touching distant worlds, warming planets that may hold life we haven't yet imagined. Every act of spreading carries with it a quiet purpose, to share energy more evenly, to create harmony through motion. If you could hear the music of the universe, entropy would be its tempo, not loud, but steady, a hum beneath all things, reminding matter and light to keep moving forward, to keep changing form. It's easy to wish for things to stay as they are, the warmth of youth, the glow of a candle, the color of sunset lingering forever. But entropy teaches us something gentler, that beauty lies not in permanence, but in flow, because the sunset fades, the night arrives, and from that stillness, a new dawn will come. So when disorder grows, don't think of it as loss. Think of it as a universe breathing, exhaling energy into new spaces, making room for what comes next. Your heartbeat, the orbit of the moon, the pull of the tides, all follow the same principle, a rhythm of giving, spreading, balancing. The same pattern that governs galaxies is written softly in every human breath. In that sense, you are not separate from entropy. You are its expression, a momentary arrangement of energy and matter, beautifully organized for just a little while. And someday, you too will release your energy back to the universe to fuel new stars, new stories, new beginnings. So the next time you watch a candle burn or a leaf drift from its branch, let it remind you that you're part of a great unfolding, a cosmos that doesn't fight disorder, but flows with it gracefully. Disorder increases, yes, but within that increase, there's endless creativity, endless motion, and endless wonder. The universe is not falling apart. It's expanding into possibility. And as you listen now, your mind slowing, your breathing softening. Remember, this gentle spreading, this calm diffusion, is not an ending. It's the quiet way the universe writes its story. One moment, one transformation, one breath at a time. Close your eyes for a moment and think back to a memory. Maybe it's the sound of rain against your window, the warmth of sunlight on a quiet morning, the laughter of someone you love. That memory feels solid, doesn't it? You can almost see it, hear it, feel it. But now, try the opposite. Try to picture a memory of tomorrow, something that hasn't happened yet. You might imagine it, you might dream it, but it doesn't feel the same. It isn't real in the same way. You can't remember the future. And that's strange, isn't it? Because if time truly moves both ways in the laws of physics, why does our mind, and every part of human experience, only point forward? Why do we have memories of the past, but not of what's to come? The answer lies partly in the nature of entropy, and partly in the fragile workings of our brains. Time, as we experience it, is a flow of change, one state transforming into another, but our consciousness records those transformations in only one direction, from order to disorder, from known to unknown, from cause to effect. Every moment you live is a result of countless small interactions, neurons firing, molecules moving, electrical signals tracing their paths. Each one leaves behind a physical trace, a change in the structure of your brain. Those traces are what we call memories. They're not images floating in space. They are patterns of matter and energy shaped by time itself. And just as the universe tends toward greater disorder, so too do our memories flow forward with it. When you recall something, you're not traveling backward in time. You're reconstructing a previous state based on those physical patterns. Your brain has changed because of what has already happened. It cannot yet change because of what will happen, because those events have not yet left their trace. It's as if you're walking through a forest at night with a lantern in your hand. The light falls behind you, revealing the path you've already walked. But ahead, everything remains in shadow. You know the path continues, but you can't see it yet. Memory is that lantern. It illuminates the trail of the past, while the future remains hidden, waiting to be discovered, not remembered, from the perspective of physics. There's nothing in the fundamental equations that says time must move forward. They work just as well in reverse. But in our universe, a place governed by entropy, information flows one way. When energy spreads and disorder increases, it leaves a record of where it's been, but not where it's going. And that's why memory feels like it is direction, because every recollection you hold is a reflection of how matter once was, not how it will be. Even the simplest systems follow this rule. A droplet of ink in water spreads outward naturally, entropy increasing, and we can easily tell which way time is moving. You never see the ink reassemble itself back into its perfect droplet form. That would mean entropy decreasing and time flowing backward. So our memories are bound to the same cosmic current. They are the footprints of entropy, The echoes of energy's one-way journey. We remember the past, because the past has left marks on the world. Tiny signatures in the shape of molecules, the warmth of fading light, the pathways carved into brain. The future, on the other hand, is still untouched. It hasn't written its marks yet, and that's the mystery of memory. It's not just a human feature. It's a reflection of the universe itself. Now, let's move a little deeper. Inside your skull lies a small, seahorse-shaped region called the hippocampus. It's one of the most remarkable structures in the brain, a quiet archivist that turns moments into memories. Each time you experience something new, the hippocampus collects and organizes millions of signals, smells, sounds, images, sensations. All are encoded into a delicate pattern of electrical and chemical changes. This pattern is stored across neural networks, like ripples in a pond that never fully fade. But here's the fascinating part. For a memory to form, your brain must expend energy. It uses glucose, oxygen, and chemical potential to create stable connections, to transform a fleeting moment into a lasting trace. And in doing so, it releases heat. It increases entropy. So, even within the biology of your mind, the arrow of time is present. Memory creation requires an input of order, and in the process, adds a little more disorder to the universe. When you remember the past, you are literally reading the record of energy that has already been spent. Your neurons have already fired. The energy has already dissipated. That's why memories are anchored to what's gone. If time could somehow reverse, entropy would decrease, heat would flow backward, broken eggs would reform, and your memories would unwind, vanishing in reverse order. You would forget the past and begin to remember what had not yet happened. But our universe doesn't allow that. The second law of thermodynamics ensures that energy disperses and entropy rises, and so memory can only follow suit. The architecture of the brain reflects the architecture of time. Even computers, our mechanical mirrors of human thought, follow the same rule. When a computer writes information to memory, it uses energy. That energy generates heat. That heat is entropy, the irreversible footprint of computation. Every bit of stored data comes with a tiny cost and energy lost to the surroundings. It's the same rule on a different scale. You see, the universe keeps perfect balance. To create something orderly, a memory, a structure, a thought, somewhere, disorder must increase. The making of memories is simply the brain's way of sculpting temporary order within the larger flow of chaos. But those temporary islands of order are what give our lives meaning. Without them, we wouldn't have stories, connections, or the sense of continuity. That defines what it means to exist. So the next time you recall a childhood day, or an old conversation, or a gentle breeze that once touched your face, know that what you're really doing is touching the residue of time's passage. You are feeling the echo of entropy, the universe remembering itself. Through you, now let's slow down even more and drift into the quiet wonder of it all. Think of memory as a mirror, one that only reflects light that has already passed. We can never turn that mirror around. We can only polish it, keep it clear, and gaze into what has been. But perhaps that's exactly what makes life so precious. If we could remember the future, if every step ahead were already known, would we still feel wonder? Would discovery mean anything If all things were already seen, our inability to recall the future isn't a flaw. It's a gift, a space for possibility, for hope, for surprise. The unknown is what gives time its flavor. Imagine a film reel unspooling in a dark room. Frame by frame, light passes through, casting images on a wall. You can look at the film that's already played, the frames behind the light, but not the ones still wound up, waiting. Those future frames exist, but they haven't yet been illuminated by the lamp of time. That lamp, that beam of light, is entropy, turning the potential of the future into the substance of the past. So we live here in the gentle in-between, where past has shape and future has possibility. We move forward not because we must, but because that's how the universe breathes. Our memories are proof that time has touched us. They are fossils of the present, hardened into thought, and as we create new ones, moment by moment, we are building the story of who we are. The future will one day become memory too. It will join the others, a vast ocean of moments, flowing endlessly in one direction. And though we can't yet see it, we can trust that it's there, waiting, softly unfolding, in the current of time. So when you wonder why you remember the past, and not the future, perhaps it's because you are a part of the universe's way of understanding itself. You are the memory of the cosmos, the living record of its journey through time. Every thought, every dream, every heartbeat is a whisper of the past, continuing its story into what comes next. And so we remember what has been, but we dream of what will be. And in between the two, time flows softly, endlessly forward. If you take a slow breath and simply look around, you'll notice that everything around you seems to follow a quiet rhythm, a sequence of happenings, each gently unfolding from the one before it. A droplet of rain falls, and ripples appear across a puddle. A seed touches the soil, and one day it becomes a tree. You smile at someone, and they smile back. This gentle connection between one moment and the next is what we call cause and effect. And though it sounds simple, it holds one of the deepest mysteries of time itself. Time moves forward because causes come before effects, never the other way around. A glass must fall before it shatters. A star must burn before it fades. A thought must form before it becomes action. Every heartbeat you feel, every step you take, follows the same quiet rule. And this rule, this universal law of sequence, creates what physicists call the arrow of causality. It's not visible, not something we can hold or see, yet it is what keeps the flow of time moving in one direction, from the known past into the unfolding future. If you could slow time down, really slow it, to watch how particles move and react, you'd still see it there, the gentle pattern of cause and effect. One atom bumps another, energy transfers, and new things begin to happen. Nothing in the universe exists in isolation, and no moment stands alone. Every instant is stitched together with the one before it, like threads in an endless, shimmering tapestry. And as we live within that tapestry, we feel time flowing, softly, quietly, forever forward. Now, imagine holding a small domino between your fingers, feeling its smooth edge and its weight. You place it gently on a table, in a line with many others, standing tall and still. And then, with just a whisper of a touch, you tip the first one over. The sound is soft, rhythmic, as one domino taps another, and another, and another. Each one falls because the previous one fell, and the motion continues until all have laid themselves down. That simple image of falling dominoes is one of the clearest ways to see cause and effect in motion. And the reason the chain doesn't run backward, the reason the dominoes don't suddenly rise back up on their own, is the same reason time itself doesn't reverse. Once an effect happens, it becomes part of the past. It can influence what comes after, but it can never undo what already is. The past sends ripples forward, not backward. This forward link, from cause to effect, builds our sense of before and after. It defines the flow of stories, the rhythm of lives, and even the structure of memory. When you recall your childhood, you remember causes first, the moments that shape what came later. You remember the choice that led to a journey, the small beginning that grew into something greater. That's causality, not just in physics, but in human experience. In the world of science, this principle is woven deep within the fabric of equations. Einstein's theories, quantum models, all carry the trace of cause and effect. Even the smallest particle dances to that same rule. It reacts to what touches it. It moves because something urged it to move. The more we look, the clearer it becomes. Time's flow is not merely about ticking clocks or moving hands. It is the unfolding of one cause leading to another, an eternal conversation between what has been and what is about to be. Think for a moment of a sunrise. It's not simply the sun appearing. It's the earth turning, the night fading, the atmosphere scattering light. Each of those steps, each small detail, is a cause and effect, nested within one another like gentle ripples on water. And so, even something as simple as dawn is a product of thousands of causes layered together. The Earth's motion, the pull of gravity, the tilt of its axis, the heat of the distant sun. All these things whisper together, and morning arrives. If we could somehow imagine a world where cause and effect didn't exist, it would be a world without time as we know it. Events would no longer follow a pattern. Things might happen without reason, and the very idea of before and after would vanish. But our universe doesn't work that way. Its beauty lies in order, in sequence, in harmony between one thing and the next. The arrow of time, the forward flow we feel, is the quiet song of cause and effect playing through every moment. And within that song, there's something comforting, because it means that everything that happens for a reason, small or grand, visible or hidden. It means that your present moment right now was shaped by countless causes that came before you, and that your choices today will ripple softly into tomorrow. The world breathes through those ripples, expanding and changing one heartbeat at a time. If you were to close your eyes and imagine shrinking smaller and smaller until the world around you began to blur, you would pass through the weave of fabric, through the surface of skin, to the layers of matter, until at last you would reach the world beneath, the world of atoms and particles and quiet vibrations. It's a strange world, silent yet alive with motion, invisible yet always there, hidden beneath everything you see and touch. And within this world, time still moves forward, but not in the way we know it. Down here, the ticking of time feels softer, less certain, less obedient to the rules that govern our everyday world. At the microscopic scale, time begins to shimmer, to behave in ways that almost feel like dreams. You see, in our ordinary lives, time feels strict. Seconds pass in order, causes lead to effects, and the arrow of time points clearly from yesterday to tomorrow. But when we look at the very smallest scales, the rules begin to blur. Particles don't seem to care much for our idea of before and after. They dance in probabilities, existing here and there, sometimes both at once. In the strange realm of quantum physics, cause and effect still exist, but not in the same steady rhythm that we experience. Instead of firm steps, it's more like a mist, a gentle uncertainty that hovers around every event. A single electron can pass through two paths at once, and only when we observe it does it choose one. Time, in those moments, seems to fold upon itself, patient and mysterious. Scientists once thought time was absolute, a single universal beat that every atom followed in harmony. But at the quantum level, it's as if each particle has its own private clock, ticking softly, sometimes slower, sometimes faster, sometimes not at all. Imagine billions of these tiny clocks, all whispering their own versions of time, like waves moving through a quiet sea. The result is a world that doesn't move forward in the same way ours does, but instead drifts through possibilities. And yet, even here, time does not stop. It simply behaves differently, gently, unpredictably, like a shadow that shifts with the light. When physicists study this microscopic realm, they often find that the equations describing these tiny events work just as well backward as forward. It's as if, in theory, time could run in reverse, and nothing would change. A collision between two subatomic particles, mathematically, will look almost identical played backward. That's where the mystery deepens, because it means that at the smallest level, nature itself doesn't seem to care which direction time flows. And yet, when all these small, uncertain moments combine, they give rise to the grand, forward-moving world we live in. Picture a single grain of sand resting on a quiet beach. To the eye, it's still, but within it, atoms are vibrating, spinning, colliding, tiny motions that never stop. Each vibration is a rhythm, a whisper of energy moving through time. Now imagine 1,000,000 of those grains, each filled with invisible motion. Together, they form a pattern, a direction, a flow. That's how our universe moves. The tiny motions of the microscopic world building up into the great arrow of time we experience. It's strange to think that the time we live in, the time we measure, is built upon countless invisible changes happening beneath everything. The heat from your hand, the flicker of a flame, the gentle hum of your heartbeat, all come from those small, restless movements of atoms. And within each of those movements, there's no strict sense of now or then. It's only when we zoom out, when we see the bigger picture, that time begins to feel one-directional. At the atomic level, reversibility is common. If a tiny collision between two molecules were recorded and played backward, it would look exactly the same. You wouldn't be able to tell which way time was moving. This is what physicists call time symmetry, the idea that the fundamental laws of nature don't prefer one direction over another. In other words, the equations describing the microscopic world work both ways, forward and backward in time. But then, you might wonder, if the laws allow time to move either way, why don't we ever see it going backward? Why do broken cups not reassemble? Why do we grow older instead of younger? Why does memory look behind us, not ahead? The answer, as you've seen before, lies in entropy, in the natural tendency of disorder to grow. Even though the microscopic world allows reversibility, the sheer number of particles working together makes the forward direction far more likely. It's like shuffling a deck of cards. While the laws of motion allow you to unshuffle it, the odds of that happening are so impossibly small that the forward direction dominates. So time, as we feel it, is the grand sum of all those small, uncertain, reversible moments blending together into one great forward movement. If you could somehow see time at both scales, you'd notice something beautiful. At the microscopic level, it's a soft shimmer, particles dancing through clouds of possibility. At the macroscopic level, it becomes a steady river, flowing gently from the past toward the horizon of the future. The two worlds are not separate, but layered. The uncertain flickers of quantum particles create the steady rhythm of the world we live in. It's as if the chaos beneath gives birth to calm above. And somewhere between those two scales lies consciousness, our own perception of time. The human brain gathers countless microscopic events: the firing of neurons, the movement of ions, the flow of energy, and from them builds a smooth, continuous stream of moments we call now. So when we feel time passing, what we're really feeling is a harmony of countless microscopic happenings, all aligned in one direction. Each instant we experience is the echo of billions of atomic motions moving together in gentle agreement. And though the quantum world seems strange, uncertain, unpredictable, it still plays its part in creating the rhythm of time that guides our lives. Perhaps that's what makes time so mysterious. It's both solid and fragile, certain and uncertain, real and dreamlike. It is built from the smallest tremors of the universe, yet it carries the weight of stars. So the next time you look at the ticking of a clock, or feel the soft passing of a second, remember the microscopic dance beneath it all. Remember that every tick, every breath, every heartbeat is born from countless invisible ripples in the quantum sea. And as you drift deeper into thought or into rest, time continues its delicate work, a quiet ballet of particles, softly writing the next line of your story, always forward, always gentle, always now. As we reach the end of this quiet journey, through time's mysteries and cosmic whispers, we begin to turn our gaze inward, because after exploring the arrows and the atoms, the beginnings and the endless forward motion, one question softly remains. What does all of this forward flow of time, truly mean for us? We humans live our entire lives under time's gentle current. We wake, we move, we dream, and through it all, time keeps flowing, never stopping, never bending back. It shapes every heartbeat, every memory, every thought that passes through the quiet corridors of the mind. But when we think about time only as something slipping away, as a countdown or a limit, we forget something deeply beautiful. We forget that time is also the reason things grow, the reason moments change, the reason life itself unfolds. The forward flow of time is not just a rule, it's a gift. It gives us the power to begin, to learn, to evolve, to move from one version of ourselves to another. Without it, everything would remain still, frozen, eternal, unchanging. And perhaps, in that frozen stillness, there will be no life, no thought, no story to tell. So when you think of time only moving forward, don't imagine it as something lost. Imagine it as something given. Each second that passes is a brushstroke on the painting of your existence. Every tick of the clock is a whisper that says, you are still here, still becoming, still moving. In the quiet of night, when you lie still and the world slows down, time does not leave you behind. It carries you forward, gently, like a river carrying a leaf downstream. You do not have to struggle against it. You only have to float, to breathe, to trust its gentle pull. Because in truth, time does not take from you, it transforms you. It turns moments into memories, beginnings into wisdom, and motion into meaning. Now, imagine time as a long, shimmering path, one that begins far behind you and stretches far beyond the horizon. You walk along this path each day, leaving quiet footprint behind. Sometimes you look back, and you see the marks of laughter, of love, of loss, of growth. And ahead, Though the view may be misty, you know the path continues, inviting you onward. This is the true beauty of time moving forward. It allows you to keep going, to discover new corners of yourself, to find meaning in the unfolding of moments. If time could move backward, perhaps we would relive things again and again, forever trapped in repetition. But because it moves forward, we have the chance to change, to heal, to begin anew. When you think about the stars, the galaxies drifting apart, the expanding universe born from that first spark of the Big Bang, you realize that time's forward motion is not just a rule of physics. It is the pulse of creation. Everything in existence shares it, from the smallest cell, dividing quietly in your body, to the largest galaxy, spinning slowly in the dark. And you, sitting here now, listening, breathing, are part of that same rhythm, the same cosmic heartbeat that pushes galaxies outward, also moves through your life, guiding your growth, your choices, your dreams. It's humbling, isn't it? To think that the same arrow of time that carries light across the universe also carries your memories through the corridors of your mind. You are not separate from the flow of time. You are time, living, feeling, unfolding within it. Each breath you take is a mark of time's passage, but also a mark of life's persistence. Each heartbeat is a small echo of the universe's rhythm, soft, patient, infinite. And though we often wish time would slow or stop or turn back, we can also find comfort in knowing that its steady movement gives shape to everything we are. Without time, there will be no story to tell, no melody to play, no love to grow. It is because time moves forward that life has direction. It is because of time's flow that moments become meaning. And so, as we reach the gentle end of our reflection, perhaps the mystery of time moving forward isn't something to solve, but something to cherish, because it means that change is real, that growth is possible, and that nothing, not even sadness, lasts forever. The same arrow of time that carries joy onward also carries pain away. The same current that pulls us from the past also delivers us gently into tomorrow. Maybe that's why we dream, why we remember, why we hope. Deep down, we feel the pull of that current, an invitation to keep going, no matter how far the horizon stretches. And in that soft, invisible pull, there is something almost sacred. Every sunrise you'll ever see, every new chapter that begins, is time's quiet promise that life still has more to show you. Even as one moment fades, another is quietly forming, waiting for its turn to arrive. And that, perhaps, is the truest meaning of time's one-way flow. It reminds us that we are travelers, not prisoners. That every passing second is not something taken, but something given, a chance to live, to feel, to love, to wonder. And when the day comes to an end, when the stars rise and silence begins to fill the air, you can rest knowing that time continues its gentle work, guiding you onward, safely, softly, always forward. So now, as you lie back and breathe deeply, let that thought settle within you. You are part of the great unfolding story of the universe. You are a ripple in the river of time, brief, beautiful, and endlessly connected to all that has been and all that will be. Let your mind drift, your thoughts grow light, and your heart grow calm. The universe is still moving, softly expanding, carrying you gently with it. Time will keep flowing, life will keep changing, and you will keep becoming. For now, let the forward flow of time carry you into rest, into peace, into dreams. Good night, traveler time, and goodbye.